Warm greetings. In this video, I am going to discuss about optical fiber. So, an optical fiber is nothing but a waveguide used in fiber optic communication. Here, the optical fiber may be glass or plastic, depends on its nature. Here, the light wave is transmitted from one place to another by the principle of total internal reflection. So, in the structure of optical fiber, there are major three parts. The inner part is called as core, within which the light has been transmitted. Then, second layer is called as cladding. Then, another one is buffer jacket. This buffer jacket is nothing but a protective layer manufactured by some polymer material. So, in the structure of optical fiber, the light will be transmitted through core material. So, in this picture, we can see the transmission of light. So, within a single fiber, there may be a lot of fibers. So, each and every fiber transmit different signals from one place to another. So, in this fiber consists of inner cylinder. This is called as core. It may be made from glass or transparent plastic. It should have high refractive index. This core material should be surrounded by a cylindrical shell of glass or plastic. It is called as cladding. The refractive index of cladding will be slightly lesser than the refractive index of core. This cladding is covered by an outer jacket. This outer jacket protects the fiber from moisture and abrasion. Here the light is transmitted through fiber by the principle of total internal reflection. This fiber guides the waves. This light waves. This is a carrier wave. Carries the information. Travel over a long distance without much loss of energy. Let us see the guiding mechanism. When the light enters to the core of optical fiber, it meets the core and cladding interface. The angle of incidence at core and cladding interface decides the mechanism will be taken after this incident. There are three mechanisms. Reflection will take place, refraction will take place, or the light can be travelled through the interface of core and cladding. Next, let us discuss the principle of fiber optic communication and also the conditions for total internal reflection. I have already said the principle of fiber optic communication is total internal reflection. For this total internal reflection, some of the conditions to be satisfied. The first condition is N1 should be greater than N2. Here N1 is refractive index of core, N2 is refractive index of cladding. The refractive index of core should be greater than refractive index of cladding. Then only the light reflect back inside the core medium without any loss. Then the second condition is the angle of incidence at core cladding interface should be greater than critical angle. Next, let's go for propagation phenomena. We have to know what is meant by critical angle. So, discuss about the critical angle. We have to study three cases. When the light enters to core cladding medium, we should consider the angle. When pi lesser than pi c, that is the angle of incidence lesser than the critical angle, the ray will be refracted into the cladding medium. So refer this first diagram A. This is the incident ray. Then next one is the exit ray. When the angle of incidence lesser than critical angle, the light ray refracted to the rarer medium. Then let's go for second case, when pi equal to pi c, when the ray passes along the interface. Okay. When pi equal to pi c, the light ray will passes through the interface of core and cladding. During this condition, the angle of reflection is 90 degree. This angle of incidence is called as critical angle. Here we can define the critical angle is nothing but the angle of incidence at which the angle of refraction is equal to 90 degree. This is called critical angle. When the pi greater than pi c, the angle of incidence greater than critical angle, the light ray will reflect back into the denser medium, that is inside the core material. That's why the second condition is given. Pi should be greater than pi c. So these are the two conditions to be satisfied for total internal reflection. So from second case, we can derive the formula for critical angle by applying Snell's law. So we can consider the diagram B. Here the angle of incidence is pi, which is equal to pi c. Then the angle of refraction is 90 degree. The N1 is the refractive index of core and the N2 is the refractive index of cladding. So from Snell's law, we can write N1 sin pi c is equal to N2 sin 90 degree. Sin 90 degree is 1. Therefore, sin pi c is equal to N2 by N1. So we can write pi c is equal to sin inverse of N2 by N1. This is the formula for calculating the critical angle of a given optical fiber. So these are the diagrams for three cases. First one, angle of incidence less than critical angle. Here the light ray is refracted through rarer medium. The second one, the angle of incidence equal to critical angle. Here the angle of refraction is 90 degree. This is the critical angle. Then third one, angle of incidence greater than critical angle. Here the light rays get back inside the core material. Next, let us go for advantages of optical fiber. The optical fibers are very thinner, then less expensive, high carrying capacity, less signal degradation and digital signals. Here we are using the light signals, non-flammable and lightweight. Let us move on to the various types of optical fiber. In industry, they need different types of optical fiber. So based on the material, we can classify the optical fiber as glass fiber and plastic fiber. Then based on mode of propagation, the optical fibers are classified as single mode fiber and multimode fiber. Then based on the refractive index profile, the optical fibers are classified as step index fiber and graded index fiber. In step index fiber, there are two modes are possible, single mode step index fiber and multimode step index fiber. But in graded index fiber, only multimode fiber is possible. The first one, glass and plastic fiber. Here, the fiber core and cladding may be fabricated from both plastic or glass. Core and cladding may be fabricated from plastic or glass or combinations. Core may be from glass, cladding may be from plastic. These are some examples for various materials used for the manufacturing of core and cladding. The next I move to the next category, single and multi-mode fiber. So in the single mode fiber, only one mode can be transmitted. So by sending only one mode with a single frequency, we have less dispersion. But this single mode fiber is very expensive to produce. So the size of core and cladding will be very lesser. So let us see the diagram picture. The single mode fiber, the diameter of the core is very small compared to the multi-mode. We can see the difference between single mode and multi-mode fiber. So in multi-mode fiber, there more signals may be transmitted. So during this multi-mode transmission, there will be some losses will cause, like dispersion. So here the diameter of the core is high compared to the single mode fiber. Then third category is step index and graded index fiber. So depending on the variation of refractive indices of cladding and core as well as outer jacket, the fiber can be classified as step index and graded index fiber. So in step index fiber, the index of refraction changes radically between the core and cladding. So refer this diagram. So in first diagram, we can see the refractive index of core and cladding changes step by step. This is called step index fiber. So in this step index fiber, single mode as well as multi-mode is possible. So in graded index fiber, the refractive index of cladding will remain same, but the refractive index of core will changes from point center to the core cladding interface. So in this graded index fiber, only multi-mode is possible. So the graded index fiber has less dispersion than a multi-mode step index fiber. So this is the comparison of multi-mode fibers of step index and graded index fiber. The first one diagram, it represents the transmission of multi-signals in multi-mode step index fiber. Then the second one is, it represents the multi-mode transmission through graded index fiber. I hope everyone can understand. Thank you.